Let's take a look at basics of graphs. And I'm going to write down some definitions, and I'll go ahead and type them up so you can actually read it. We got our X Intercept. This is where the graph touches or crosses the x-axis. We have our Y-Intercept. This is where the graph touches or crosses the y-axis. We have our domain, and this is where the graph exists x value wise. That's a word. So we're looking at where it exists on our x values. Now our range is where the graph exists y value wise. Probably not correct English, but you get the idea. We have zeros. This is where the graph touches or crosses the x-axis. That may look familiar. That's same definition I wrote up there for X Intercept. Well, let's take a look at some problems. Our first one here. Okay, so we're given a graph, and it wants us to find the domain and the range. So let's start there. Now our domain is where our graph exists x value wise. If I come here at x equals 1, the question becomes, can I go up or down if I'm a graph? Yeah, if I go up, I find my graph. It's right here. Over here at x equals -3, can I go up or down if I'm a graph? Yeah, go up if I'm a graph. If I come over here to x equals -100, I can't find my graph. Well, this keeps going forever. So over here at x equals -100, if I go up far enough, I'll find my graph. Over here at x equals 1 million, if I go down far enough, I'll find my graph. So it exists actually x value wise everywhere. So domain would go from -infinity to +infinity. Now our range, our y values. Y values, you go right and left. Well, if I come here to y is equal to 1, if I go right, I find my graph, so it exists there. If I go down to y is equal to -2, if I go right, I find my graph. If I come down here to y equals -50, if I go far enough to the right, I'll find my graph, so it exists down there. If I come up here to y equals 1 million, if I go over to the left far enough, I'll find my graph. It exists up there. So it actually, our range goes from -infinity to +infinity. Now B asks us to find our intercepts. So let's look at the x-intercept first. The x-intercept is where it crosses or touches the x-axis, which looks like it's 4, 0. Now our y-intercept. Our y-intercept is where it touches or crosses the y-axis, which is 0, 2. And then C says find the zeros. Now zeros is where it touches or crosses the x-axis, which is at 4. And we write this a little bit different. You may see it written as x equals 4, or they just may write 4. It's the same number as what you got for the x-intercept, just a different way of writing it. Okay, let's look at our second problem. Same instructions. So first thing we're going to find is our domain, where it exists x value wise. I know this is pretty small. Here's x equals 4. If I go down, or well, actually it's right here, it crosses a 4, so it exists there. If I go to x equals 6, if I go down far enough, I'll find it. Because as this is going down, it's slowly going to the right. Slowly going to the right, it'll keep slowly going to the right, keep slowly going to the right forever, keep going slowly to the right forever, until it goes to +infinity. Now this over here, as this is going down, it's slowly going to the left, slowly going to the left, it'll keep slowly going to the left forever, until it goes to -infinity. So our domain is -infinity to +infinity. Now our range. Your y values. Well, as it goes, you see it's pretty well going straight down, so it's definitely going down to -infinity. But if I come up here, this is y is equal to 9 right here. That's the highest point of my graph. So this is going from -infinity to 9, and I'll put a bracket on the 9. You can pretty well assume it'll always be a bracket on a number, unless you see an open dot. Looks like an open circle on it. Well, our x-intercept in Y-intercept. X-intercept is where it crosses the x-axis. Well, it looks like negative 2, 0, 4, 0. So it'll be negative 2, 0, and 4, 0. Our Y-intercept is where it crosses the y-axis, which looks like 0, 8. Now our zeros. Well, that'll be x is equal to negative 2 and x is equal to 4. Or you might just simply see negative 2, comma 4. Let's take a look at one more of those. Okay, so same instructions. So we're going to find a domain and we'll find a range. Domain is our x values where our graph exists. Now you see this arrow here keeps going forever. So it's going down, going down. As it's going down, it's slowly going to the left, slowly going to the left. It'll keep slowly going to the left forever, so it's going to negative infinity. Now over here on this side, see how it just stops right here? If I go to x equals 5 and I go up or down, I don't find my graph anywhere. So 4 is the rightmost point of the graph. So our domain is going to go from negative infinity to 4. And remember, we put a bracket on numbers. Now our range. Well, this is going down forever, so it's obviously going to negative infinity in my y values. The highest point is right here, which is y is equal to 7. So this is going to go from negative infinity to 7. If I come up here to y is equal to 8, if I go right or left, I don't find my graph anywhere. Now our intercepts. Now our x-intercepts. Crosses negative 2, 0 and touches at 4, 0. So we'll have negative 2, 0 and we'll have 4, 0. Our y-intercept is 0, 7. And then C says to find your zeros. Well, we'll have x is equal to negative 2 and x is equal to 4. Or I could simply write as negative 2, 4. That looks familiar. That's what our last problem was. Sure enough. Same points. Okay. Now that's how to do it graphically. Let's talk about how to find some of these items algebraically. That's what the next problem indicates. It says find the x-intercept and y-intercept. So we got y is equal to 5x minus 20. Now to find the x-intercept, you always plug 0 into the other variable. So to find the x-intercept, we're going to plug 0 in for y and solve. You have to know linear equations in order to do these. So plug 0 in for y. So we got 0 is equal to 5x minus 20. And we want to solve. So I take negative 20 to the left side, gives us positive 20, equals 5x. And then divide both sides by 5. And we get x is equal to 4. Now you could leave it in that form, or if you want to put it in point form, then you could do that. Different books handle that different ways. You should be familiar with both, to be honest. Now that's our x-intercept. To find our y-intercept, again, you always plug 0 into the other variable. So we plug 0 in for x and solve. So we got y is equal to 5 times 0 minus 20. Well, 5 times 0 is 0, so that drops away. We got y is equal to negative 20. And if I put it in point form, it would be 0, negative 20. And those would be your answers. Let's take a look at one more of those. And I may start a new page, just so I have room. Okay, we got 1/3 x minus 1/5 y equals 2. And we want to find the x-intercept. Again, you always plug 0 into the other variable. So we're going to plug 0 in for y. So we got 1/3 x minus 1/5 times 0 equals 2. 1/5 times 0 drops away, and we got 1/3 x is equal to 2. Now this is a linear equation. First step, get rid of parentheses, don't have any. Second step, get rid of fractions. Multiply everything by the LCM of all your denominators. We only got one denominator, so our LCM is 3. So multiply both sides by 3. Those 3's cancel. And 3 times 2 is 6, so we get x equals 6. And if I write that in point form, that'd be 6, 0. Now for our y-intercept, you always plug 0 into the other variable, so plug 0 in for x. So we got 1/3 times 0 minus 1/5 y equals 2. 1/3 times 0 drops away, so we got negative 1/5 y is equal to 2. Now it's a linear equation. First step, get rid of parentheses, don't have any. Second step, get rid of fractions. Multiply everything by the LCM of all your denominators. We only got one denominator, the 5, so that is our LCM. So multiply both sides by 5. And that 5 cancels that 5. And we got negative 1y is equal to 10. Still don't have the y by itself, so now we'll divide both sides by a number in front of our y, which is negative 1. And we get y is equal to negative 10. And if we write that in point form, it'd be 0, negative 10. And that's our answer. Let's take a look at finding the zeros. These are actually the same steps you use in college algebra. The problem's a little harder to solve, but we're still doing this exact same idea. Now to find a 0. Now you probably could figure this part out, because we know that we've seen earlier that 0 is kind of the same idea as the X-intercept. But to find a 0, we're going to plug 0 in for y and solve. Now remember, your function notation f of x, that's the same as y. So we're going to have 0 is equal to 2x plus 10. First step, get rid of parentheses, don't have any. Second step, get rid of fractions, don't have any. Third step, get everything with an x on one side, numbers on the other. So I'll take 10 over. It becomes a negative 10. And last step, divide both sides by forgot my x. Divide both sides by the number in front of your x, which is 2. So we got negative 10 divided by 2 is equal to 2x over 2, which gives us negative 10 divided by 2 is negative 5, so x is equal to negative 5. One more. We got f of x is equal to 16x plus 3. Again, to find a 0, we'll plug 0 in for y, so plug 0 in for the f of x, and then solve. Well, first step, get rid of parentheses, don't have any. Second step, get rid of fractions. Multiply everything by the LCM of all your denominators. We only have one denominator, so we'll multiply everything by 6. So 6 times 0, 6 times 16x, and 6 times 3. Well, 6 times 0 is 0. Here these 6's will cancel. And we got x plus 6 times 3 is 18. Then take the 18 over the left side. Becomes a negative 18. And we get x is equal to negative 18. And those are our answers.